In this video, we are going to see about EDA Playground, which is one of web-based cloud application where you have different simulators, synthesizers, and various tools to perform certain tasks. For our course, we will be mainly using this EDA Playground to perform all the hands-on that we are going to do in the upcoming lectures. So here I'll give you a brief of how to use this EDA Playground from very minute details. The place where you are seeing this logo, if you directly click on this particular logo, you will be able to reload the entire application and you will get some blank screens. And here is a run option where if you want to run, if you want to run your code, you can just click this button. And copy is another option where you can copy the same. It's kind of a duplicate. If you want to duplicate your playground, like current playground, you can use this copy option. And here this option says like if you want to set certain shortcuts for your EDA Playground, let's say some shortcuts, keyboard shortcuts, you can use this menu. And this is to documentation of EDA Playground, wherein if you stuck at some point, you can directly refer to this documentation. It will have a detailed information about complete whole of this EDA Playground. And here you have two options, your playgrounds, where basically you have all the playgrounds that you have written, and published playground is a place where you can see certain already pre-existing playgrounds that were done by some other people. You can use some basic examples over there. If you want to execute some basic examples from there, you can view them. And profile is a place where you can give your information, and it also have an logout option. Basically, if you want to use this EDA Playground, you need to log in first using some mail ID. So here you have certain languages. Mainly we will be using systemverilog throughout this course. We'll be sticking to this particular option throughout this course. And here certain methodologies, we have verification methodologies. As and when we are needed to use these options, we will be using accordingly. As and when the time comes, I will be letting you know all these options about this particular methodology section. And we have certain other libraries as well. And here we have certain other options. These will be mostly we will not be using at the beginning part of our tutorials. We will be mostly using at later part of the course, like TL Verilog, enable TL Verilog, easier UVM, VUnit. All these are certain options on top of this thing. So we'll be seeing them little later. And tools and simulators, mainly we have certain simulators here. I'll be using Aldec or Synopsys VCS mostly for all the lectures. Anything works fine, but there might be some deviation of options and all those stuff. Mostly these two things work for us. So compile options and run options will be automatically taken by this tool. We need not worry about. If we need certain compiling options or running options, we need to modify accordingly. So runtime is a place where you can specify certain runtime here. And here you have another bunch of options. Run.do TCL file, one option. Like if you want to run through TCL file, if you want to run through shell script, or if you want to view the waveform, then you should enable this option. Like if you want to show output file after running, you just click this and you need to name the output you want to see. And download files after running, if you want to download all the files after running, you can also enable this option. It will automatically download the files once it runs the thing. So here comes the main thing. The right hand side one which you are seeing, the one which is highlighted, is basically the design under test. Like mostly our design lies on this right hand side. And the one which is on the left hand side, which is highlighted, is the test bench. On the right hand side we have design, on the left hand side we have test bench. Basically here we have taken deep flip-flop, the behavior of a deep flip-flop. For now just ignore what deep flip-flop do and all those stuff. It is a design, a digital circuit kind of thing. and the test bench is written accordingly for that D flip-flop. So if you run this this particular thing, this is a log or console where you will see all the output. So it is successful, and you can see all the options or all the output that you are getting. The simulation has finished. There are no more test vectors to simulate. Simulation has finished. So all the test vectors, as we have seen in the theory, like here there were certain test vectors, all these were simulated, and the design is also running accordingly based on the test. This is the way that we will be using this design and test bench whole our course, and this is completely EDA Playground, where we will be exercising all the hands-on experiment in our course.